Hello, my name is Jay Stark, and this is my Lab 2 charge tape revisited. Alright, so the introduction. So the purpose of this lab was to revisit and further investigate the data from Lab 1 by making a more accurate and computational model to simulate the charge on the tape. Instead of representing the tape as a point charge, we decided to represent it by a line of charges. And the results were that the magnitude on the piece of tape was 2.4 e to the negative 8, almost double, well exactly 2.24 times the magnitude calculated using the computational model from Lab 1. So the models used here was the experimental model and data from Lab 1, and the new computational data using line charges, not the point charge. Alright, so the equation of key constants that you had to know was Coulomb's law electric force, which is force of electron is equal to the constant first charge multiplied by the second charge divided by the distance squared times r hat, or just the second charge times the E net. The gravitational force, which is just force of gravity, is equal to mg. Force of Newton's second law, which is force of net equals the momentum divided by the time difference. The electrical field distributed charge, which is just E net, is equal to all the electric forces added, which is just superposition, and the charge of an electron, which is 1.6 times 10 to the negative 16th. Alright, so experiment 1 recap. So two pieces of U tape was given charge by quickly pulling a tape from another piece of tape to charge the U tape, and the U tape was determined to have a positive charge after the first part of the lab, where a pen with a negative charge was put against it, showing it was positive. So you can see the pen which had a negative charge, and the tape stuck to it because the tape is a positive charge. Now then, one piece of tape was taped on two rulers, and what was at the bottom to see how it would react. The tape on the ruler began to float due to the charge being the same. So you can see how, since two charges are the same, the tape started to lift. Alright, so this piece of tape came out to be around 2.3 centimeters. So the lab 1 data, so the experimental data was from the lab 1 was the length of the U tape was 20, mass was 2 times e to the negative 4, the distance was 2.3 meters, like I stated before, gravitational force is 1.962 e to the negative 3, which is just solved by the mass times gravity. Electric force, which is equal to gravitational force, which was 1.962 e to the negative 3, charge was 1.07 e to the negative 6, and the electron loss was 6.7 e to the 12. Now the computational data that we got was electric force was 1.962 e to the negative 3, which is the same as the experimental data, but the charge was 1.07 e to the negative 8, which is what we're going to be using for our next computational data, and the loss was 6.7 e to the 10. And you can see the lab experiment before, which was like this, where there was 2 point charges. Now, the new computation model we're going to make, instead of using just a point charge like earlier, like you saw here, we're going to be using multiple charges that look like this, where we simulate a multiple charge going up with the same electric charge, with the same force up, and gravity down to get a better understanding of the forces on the tape. Now the assumptions we have to make is air resistance is negligible, each piece of tape have the same charge, and the charge on the tape is equally distributed along the length. Okay, so here's the code, where here we're just going to name the constants, which this is just the constant, 9 times e to the 9, gravity, the length we stated earlier was 0.2, separation was 0.02, well, 23 meters, and then the U tape's length was 1 over 1000. The differential factor, which we had to solve by hand to make sure the gravity and the electric force was the same, came out to be 2.24 around, and this is just to help solve for the cube. And then right here is just the electric force equation, and right here it just shows how the lines were made, where we said that on the line charge there's this amount of quarks, this amount of circles, where they all have the force on them. Okay, so here this part shows how exactly each charge was made, or so each charge was put on a line, depending on the number we were put here, which is 25. I decided to do 25, and then from left to right, it put every single charge with a certain distance between them to make sure we can simulate the charge line. And then over here is a for you loop inside a for you loop that put the force on the charges that we created earlier with this here. So we made the charges here, and then this for you loop put the charge on each one of them, and then add them all up to get the full net charge. Now, the data found about the charge right here was that the gravitational force was 1.962 e to the negative 3, and we had to counteract that by trying to find the electric force, which was, I tried my best, it was around 1.94 times e to the negative 3, which means that it was manually estimated to be around 2.4, which is around 2.2 times more than the estimated charge on the U table on part 1. The possible source of error that could have occurred here was the error in lab 1 with the separation of tape, and the error with external forces present in the observable data in lab 1, such as like the air might have affected the experiment in lab 1, and the charges on each piece might not be equal. So like right here, we just estimated, we guessed that everything was equal, but it might not have been equal in the actual charge. Okay. So conclusion and discussion. So if if you have modeled each of the tape as a single point charge like the previous lab, so lab one, how would it be different? So if the computational model had the same single point charge instead of a line charge, its charge observed at the end would have a difference of almost 44% because it went from 1.07 e to negative 8 to 2.4 e to negative 8. And why do these estimates differ? Which value is more likely to be closer to the real value and why? So these differ because the point charge is just like an oversimplification of the experiment, while a line charge would be a better estimate of what the actual charge of the tape looks like. Therefore, the tape charge is a more accurate value to represent the charge of the tape. All right, that was my lab. Thank you.